Greetings of the day. This is group number 18, and today we are going to present a reviewed session on a project real time traffic sign detection using YOLOV5. I am Akshit Walia from ECE.
My name is Sarthak and I am from ECE.
My name is Vedanth and I'm from ECE.
My name is Kunal Sehrawat and I am from EC.
My name is Aditya Singh and I'm from EC. So, to start off with introduction, the street or the road signs around us were old by historical standards. To counter this, milestones that indicated distance or a path were the earliest road signs. Over the past decade, autonomous cars have generated much interest within academia and the industry, especially in urban environments. Fast RCNN and faster RCNN are two new developments in object detection that offer forecasts of hundreds of milliseconds to seconds. Moving on, we have the need for this project. Roadside is a significant health and development concern for the general well-being of public. According to a report, road accidents in India in 2020 were around 3.6 lakhs. The primary goal of this project is to offer an effective method for detecting and identifying traffic signs in India so as to help the drivers drive more attentively and professionally. Moving on, we have the components of the project. The first component of the project is Raspberry Pi, which is a small single board computer for computations regarding the project. Now, the second component is the Linux, which is an operating system that we have used for the implementation. And the programming language that we have used for software implementation is Python. Raspberry Pi camera module is the module which will detect the traffic signs.
Now moving on to the data set, we have used German data set for the training purposes. So we divided our data set into three subsets. 50% of data set was used for training purposes, 25% was used for validation purposes, and on the remaining 25% we tested our model. Basically, we applied stratified sampling. One thing which we made sure was that overall class distribution is preserved for each individual set, and that all images of one traffic sign instance are assigned to the same set, as otherwise the datasets could be considered stochastically independent. Now let's talk about the flowchart. So basically, how this is how our model works. First, like the Pi camera will extract the video frame by frame, and the frames would be sent to the Raspberry Pi. There would be some pre-processing which will happen at the Raspberry Pi, and for example, like reducing the size of the image, and then that image would be fed to our model. Our model would detect if there's any road sign present or not. If our model doesn't find any road sign in the image, it will simply discard the frame. If it finds an traffic sign, it will recognize which sign it has found on that image, and then an alert message will be displayed on the LED screen, which will be mounted on the dashboard of the driver screen.
Let's move to the methodology now. You look only once is known by the acronym YOLO. This algorithm identifies and finds different things in a picture in real time. YOLO algorithm works using the following three techniques: residual blocks, bounding box regression, and intersection over union. The picture is first separated into grid cells. A single convolutional neural network is used to make all of the predictions at the same time. Intersection over union assures that the expected bounding boxes of the objects are equivalent to the actual boxes.
Now
Now
this is
let's
our demonstration.
And these are the mean accurate precision losses that we got. And finally, moving on to the conclusion, the basic idea is to recognize and classify the traffic signs from an input image. The image processing technique used in the system is based on the YOLO-V5 algorithm. Finally, the recognition and classification of these potential road signs are done according to a database of the road signs. In the future, we hope to transition the architecture to more mature framework, such as a cafe or a torch, to support a quicker development cycle. And the YOLO model has delivered what it promises: fast speed, optimal accuracy on lightweight model. So here we tested the model and we got an accuracy of nearly 97%. So thank you so much.